So we're at the Regional Science Center. So we're coming in. Let's see. Let's look at this. It doesn't even have anything. It's not creating anything. Propeller fan. Let's see. So for this propeller fan, you have to press the switch so the air is blown on the fan blades inside the cylinder. So the blades start rotating and also moving up. Yeah. Now rotate the knob after control for air by opening. Look at that. Rotate because of the pressure of air from below. The way of turbine rotates in a hydraulic turbine. The rotation of generates sufficient thrust to lift the fan up. When we start covering the top of the cylinder, the air hits the top and gets reflected to generate the reverse thrust on fan blades.
फैन डाउन आ गया क्यों आया मैं आपको बताऊँ क्या हुआ है जब उसके ऊपर कवर हटा रहे हैं थ्रस्ट जनरेट हो रहा है थ्रस्ट क्या कर रहा है फैन को लिफ्ट कर रहा है जैसे उसका
So basically the thrust is what reflects it, and when it's covered from the upper side, the fan does not go up and does not rotate properly. Let's go to the other one. So this is all roads lead to Rome. For this, we have to put one of the striker in focus 1 and the second one in focus 2, and they have to be parallel here. So when we hit the striker, in whichever direction we hit, it comes back to hit it. See? So for this one, the two strikers is on the circular marks to shoot one of them in any direction towards the curved peripheral, because that every time it returns to hit the striker kept on the other circle, because the curved peripheral of this frame is in the form of the eclipse as written here with two curved circular marks at its see the striker comes from the one focus to other one to be reflected to other by the eclipse boundary, this one. So the property of this eclipse is valid for all kinds of waves. If you all kinds of waves means if we shoot from any direction, look, shoot from here, it returns there to hit it. So let's go to the other one now. So for this one we have planetary motion. Let's first look at the ball. Yeah, let's first look at the ball. already clicked. So, as it's written here, the ball, we had released it from the top, and to observe it, the ball starts moving slowly, as we had seen, but then it gets fast. When it comes to the bottom, it gets fast. So, why does it do that? Because of the centripetal force on the moving ball. It increases the radius of as the path decreases. This is also the reason why planets nearer to the sun move faster along their orbits than those which are farther away. Let's see it one more time. She's going slowly. Slowly it increases its speed. Now it's going even faster. The fastest is in the bottom. Not here. Yeah, here. So freaking fast. And there it goes. It's back here. So let's move on to the other one. So for this one, this is called air pressure. So engineers normally use this for knowledge of air to generate energy from wind, basically. In Fly High, you can try out some objects flying in the wind tube. Just leave the objects inside the tube, observe how they lift it up. Now let's see the experiment first. It's too heavy. Okay, so would you look at that? Just a short intermission. This doesn't happen regularly. So yeah.
Tornado.
It's a tornado. Look, the air. See, there's something flying inside it. I don't know what. Can you see that? No. I honestly got terrified. Okay. So, in this tornado, it is a violently rotating column of air that can cause devastating effects. Warm and moist air rises from the ground and forms huge clouds in the sky. That's what's happening. And there's a bit of rain. So, sometimes rising air spins the surrounding clouds and creates a vortex. Air cools down and condenses as the pressure of the center. The vortex is reduced. Surrounding air at the higher pressure tries to rush into the center. A slight difference in the pressure between the center of the vortex, the atmospheric pressure at the ground, pulls the vortex to the ground. Now we have to press the switch and observe it, which we are already doing, so there's nothing to worry about. Let's take it from the very... Oh no. Okay. So as we have noticed, the paper went up from the air pressure and came down. That's what happens here. How does something long and skinny fly in a wind tube? What about something flat? Yeah, that's what we did. Paper is flat. So yeah, a type of flat. Air is a type of fluid like water. It can't carry or push things because of its energy, and that's what happens in the exhibits wind tubes as the air flows upward of them. However, other forces can fight against these. Being carried by air, gravity pulls downward. For example, so heavier things are less likely to be pushed up, which is the plastic that we used before. And when it has more surface area to push against, the object can fly higher and faster. Propeller can also create lift by redirecting the air downward. Let's move on to the next one. So, where are the fun mirrors? And it's written here, stand in front of different mirrors and see yourself, sometimes thinner, fatter or inverted. Move further and closer to the mirrors and observe the changes in your image. close observation will give you an idea of the relationship between the curvature of mirror and property image of image. I'm so freaking fat and small. So this mirror is like this inverted from the side. Yeah, this one. It's which one is that? I think. Yeah, I think it was this one. The concave mirror, virtual and erect image. So this is the no, wait. It was the convex mirror. So this is the object. I was taller, and then I was fatter and smaller because of these grains that we had studied before. So this was the convex mirror, and this is the concave mirror, I believe. Oh, I'm thin, and I'm slender right now. Great. So I'm thin and I'm taller. This is the concave mirror. So here is this. I'm the object here, and because of these lines or the imaginary lines, I'm this image. Then this image becomes like the mirror part of me. So let's move on to the other mirror. Which mirror is this one? Oh, I think I know. Wait. I think it's this one, real inverted, same size. Because this object hits in and comes back, it's forming this, right? Yeah, it's like same size. There are literally only 3 mirrors, so let's go ahead. So guys, this one is called Bhavan, and it's forming a water circulation. So we have to press the switch, which already done. After a few seconds, a perpendicular shape is formed in the water column, like this one. The shape is known as vortex. So a pump draws water from the bottom, this one, and injects it diagonally at the top. Of the column. Now the tangential entry produces centrifugal force on the water molecule and it rotates as suction water due to the pump exerts a downward pull on the water at the center. See, as it's making, because of the air, it's going up and it's rotating because of the force. And a combination of rotational force and downward pull results in formation of vortex. See, the downward pull of water and the rotational force of the air which is coming from downside is forming the vortex. And vortex do not form a stagnant water. Presence of centrifugal force is a must for the formation of the vortex. On to the next one. Look at it. So this is called as the Fresnel mirror, and I'm not gonna talk about it. It's weird. So it's stand on the mark and look at the mirrors. Can you see multiple images of a face in ordinary mirrors? Sorry. Yeah, I can. Only my head though. So shift to left or right. Now multiple images. The alternate mirrors are forced to get the mirror of a person standing in one position. This that's why it's only showing my head. A person height of 150 centimeter, which I'm not. If you are taller than this, you can bend to see. I have to jump. Let's see if I can capture it. So here we are. Let's move left. Right. It does not capture anything. The other one is called the mirror wall. I'm just gonna take a picture. So it says, can you see a broken image? Yes. Here plane mirrors are placed on the wall at different angles. As you can see here, I'll show you from here. Look at it, it's not in a straight line. That's why it's showing a broken image of me. I mean, look at it. I'm headless now. Great. So, light reflected from our body reaches the mirrors, and depending on the angle of mirrors, they get reflected back in different directions. Image for a part of your body is only see for which reflected light reaches your eyes, hence you see a broken image of yours. Let's get our head back. I don't think we can, at least not yet. Move this side. Okay, now I'm legless, I'm headless, and I'm legless again. Right. Let's move on to the next one then. So this one is called Infinity Well. Let's look inside the wall. Well, it seems endless, doesn't it? Well, it's not. Can you guess its depth? The well is just 2 feet deep. There is a mirror at the bottom. The top glass is a half mirror. Allows you to see as well as its lower surface at the first side wall. So 2 parallel mirrors creates the infinite depth. Is this half? I don't think so. Okay. Can you see the little half and half down there? Well, I can. See, look carefully. There is the half one first one, and there is the second one. So that creates like an infinity image. I don't trust them. I think it's infinity. Oh, on to the next one. So this one is called the message from the depths. Ooh, creepy. So it says push the handle back and forth and observe the bubbles rising in the tubes.
Take a photo.
Look.
3 seconds. It will be 3 seconds. Okay.
Let's see. Ooh, bubbles. Just want to pinch them. So, as we can see, the bubbles rise up as the pressure exerted on it from all sides by surrounding liquid dimensions. Since the pressure is directly varies with the length of the liquid, which I don't know what it is, another column above the bubble. As a result, the air bubbles expand and grow in size. Or grow in size. I don't know, it's grow in size. For liquids with different densities and velocities, the rising bubbles behave differently. And we also have to observe that the bigger size of the bubble moves faster than the smaller bubble. The increase in force of buoyancy on the bigger bubble is much higher than the increase of resistance on it. Let's see. Oh, that's a big one. Now let's see small one. Oh, it takes time. It's right. On to the next one. So this one's called Super Bounce or Uchhal. It says lift any ball and release it. Let's see. We lifted it. Release. Oh. Okay. So we observe that the ball bounces back to a level lesser than where you dropped. Yeah. The ball, this is because some energy is lost due to the friction and inertic impact. So now let's observe it again. It does. We left it there and it dropped like here somewhere. So we've also observed that the smaller ball bounces back to a greater height, whereas the larger ball bounces very little because of its size. And see, it went up. I thought it was stuck for a moment. So after the impact of momentum, that is mass into velocity of the ball, mostly gets transferred to the smaller one because it's the one which is the most higher. So it bounces back to the greater height. So theoretically, if you balance a table tennis ball on the stack of 9 other balls, is much then more massive than one above it. The ball dropped from a height of 5 meters and the ping pong ball would end up traveling like the one written here, 10 kilometers per second. So let's go. Oh my god. One more time. Let's record it. Go. Oh my god. Okay. So the velocity is fast enough to escape the Earth's gravitational field. So okay, to the next one. So now we're going to watch the 3D movie. I don't think the mobile is allowed there, but I'll try to do so. Oopsies, we went the wrong way. Sorry. But there's a 3D film show. Let's hurry. Please stop making the announcement. So I hate that one. I don't know why it's creepy. Ooh, let's go. We're here. So for this 3D one, I'll just take it. It's too much to explain right now. There's the door, but you can see it obviously. So we're going inside. If it's not allowed, I'll end the video. I don't know there. I'm wrong. Okay, we're gonna take this one straight. Let's go. Let's get the goggles. Goggles. Look. I look at this, don't I? Let's go.
अब ये रोएगा देखो कैसे चिंगारी मार मार के अब देखो कैसे रोएगा नहीं रोएगा वो ले भाई प्रिंस
3D ग्लास में लगा के
3D ग्लास ला दो
क्या इसमें कैसे लगेगा
लगा दूंगी
बेटा दोनों
not be able to see the 3D, but I will explain everything. It's terrific.
Confront a number of crucial environmental issues, which, if left unchecked, will greatly affect the future of the world as we know it, and perhaps the survival of the human race.
A few moments later.
We're done with the movie. It was fantastic. I couldn't show you. Sorry, it was not allowed. So it says, please do not touch the ball. Okay. To interrupt pendulum settings. So it said, Foucault's pendulum. Here is a pendulum that demonstrates the diurnal rotation of Earth. I don't think it's moving correctly. Watch the direction of swing of the pendulum carefully. After a couple hours, please visit the pendulum again. Check its direction of swing. The pendulum plane will apparently shift clockwise at a rate that depends on the latitude of the plane. The clockwise rotation can be easily shifted from north pole, where the shift would be maximum, being one rotation each day, whereas each rotation takes about 1.5 days. Oh, is it just me or did it change? It is doing from here and here. Now it's moving completely. On to the next one then. This says sympathetic swing. Oh. So apparently, let's first see. It says we have to pull the bob and release it. So, wait,
सिंपल है तेरे को बताएगा दूसरा मुझे नहीं पता
okay, let's get a photo. Let's see. Observe how the motion of this bob is slowly transferred to the other bob. Yeah, it was moving slowly and now it's faster. So also observe the point of time when the motion bomb is maximum, the first bomb virtually stops. Then the motion of the second bob is again transferred to the first bob and the whole cycle goes on. When the oscillation of one bob is opposing phase is out of the metal strip, the bob stops. Where the oscillation of the bob is maximum, but it is in the same phase. See, the middle strap is controlling all this. If I do it like, wait, I'll just stop that one. Okay, now I'll release this. And now see, it's transferring there. It goes there and there. See, now it's moving faster and it's getting slower. On to the next one then. So this one's called it's a chaotic pendulum. Okay, turn the knob and release it. Oh, it's like it has its own spirit. Okay, we've done that. Watch the oscillations of the swinging pendulum. Okay. So the chaotic and unpredictable, and the T-shaped one pivoted member at the center connects all three pendulums. Just like the center is the main frame of a wheel, but this is chaotic. That's not. When they swing, the oscillation of each imposes sympathetic situation of others with interaction creates unpredictable oscillation movements. Oh my god, what's happening? Okay, now on to the next one then. This is called a sympathetic swing. Let's see. First we have to pull one bob to extreme and release it. Okay. Oh, it's slowly moving. I just realized that. And done. So, observe how the motion of this bob is slowly transferred to the other bob. It's same as the other sympathetic swing, which had y-axis, but this one has x-axis. So that goes front and back. This goes right and left. Oh, that's stopping. It's moving to its maximum. Yeah, the oscillation of the bob will be maximum phase. On to the next one then. This one's called Badalte Rang, changing colors. Let's see what it says. We have to look at the screen. Okay, there are outlines. Now look in the screen through the screen plays. Oh, it's colorful. The dog's blue. Now from here, it's gray. The color changes. So it's because the pieces of the tape rotate in planes as possession of the constituent colors of light passing through it to different degrees. And on to the next one then. So this one's called rotate the disc and observe. Peek through the hole and looking in the window, you will see beautiful symmetric patterns. Oh yeah, I do. Now let's rotate it. How am I supposed to rotate it? It moved. Okay. So with the handle and the pattern changes. Here 3 mirrors are placed at 60 degrees forming equilateral triangle, as you can see. So colorful objects are placed at the right angle. So okay, on to the next one. We're going Tara Mandal. So I think that will be the next one. Let's go. I'll pause it here. Okay. Woo. So it is a serious science lab, isn't it? This is Innovation Hub. That's the exhibit lab stores. This is Taramandal. Here we are. So I took on my shoes. Let's go inside Taramandal. My legs.
साइलेंट करते हैं.
I'll have to pause it. I'm sorry. But I'll do capture this one.
A few moments later.
Just for the recap. It's changing. It changed. Nice. On to the next one then. This one's called Float the Balls. Because of the energy that is coming. The ball! You need to higher because then you get cabin. What's it for? What's it for? My turn. And it. So it's going up. Adapt to the bicycle as you pedal, the blower throws up the air pressure lifts the ball. I'll try that once. On to the next one then. So this one's called Yadui Null or Magic Cap. Because if you have a sign from where does the water come from? Is that magic? No. See? If you have a scientific approach, you will be curious, you will investigate, you will you will check your hypothesis. What the heck? They're not telling. So see. What I think is when the water is filled, it is attached from here, then the water goes down and comes back to the tap, and then the tap releases the water into the bucket. And on to the next one then. So this one's called acrobatic stick. So this stick is passing through a curved line. Oh, because of its axis. If you draw a curved line, it wouldn't go through there. Because it's arranged like that. So it says that press the button as we've already done, and this is happening, it's moving. So the rotating stick generates 3-dimensional surface hyperbolically. The curved slits through which the stick passes are found in hyperbola. This is This form is obtained by the intersection of hyperboloid with a straight transparent surface at the middle. Observe that the hyperbolic cane seed is made up of straight sticks. Because if you pass it through there and draw line, sounding line, it wouldn't go because it's arranged like that. So now to the next one then, I think. So this one is called a head on the platter. That is the entry. So stand in front of the exhibit and observe a fruit plate on the table. Ask your friend to go inside the enclosure and lift his head up to the fruit plate. ऐसे रहने देना हाँ. So there's the fruit plate. I'm going inside. This happens because you will find your friend hide among the fruits with his or her body vanished. The table with the fruit plate at the top has mirror surface on two front sides. Images of the floor and the wall found in the mirrors creates an illusion of a hollow table, and the body of your friend appears to vanish through absolutely blind mirror. So what happens is the mirrors that are attached are facing these walls. That's why the walls are created side by side. So it looks like that there is no mirror facing us, but there is a head on the plate and the body is vanished. Then on to the next one then. I guess this is the end of the inside. Oh wait, no it isn't. So this one's called energy ball. Here is the maze of circuits path along which energetic balls go. Runs through the tracks like an acrobatic circus. See that it's here, but they're playing it. They've created paths which depends on what it is. It's the different paths. Never mind. So these were, I want to see that one. And anyways, these were the paths. It's repeating again and again. The machinery. So they now possess potential energy that depends on the height through which they are raised. Once these energized balls start rolling down different parts of the maze, their potential energy gets converted to kinetic energy. Performing a journey part of their energy results in friction. Oh wait. I want that to come down. That one's stuck too now. Well, okay, let's leave it there then. from the end of the insides. This one's called sand art. The simulation shows the locus of a point moving along a radial arm of a rotating spring. Press the switch. The ball isn't there. The ball isn't there. Oh, I guess that's a fail then. Next. So apparently this one's called Ghumati chain. It's called Ghumati chain. Rotating chain. Let's see if I press the button, what happens. It's rotating fast. Oh wait. Okay. It said wait because it's too fast. When you observe the chain hung from the top, I'll just observe the chain hung from the top. Press the switch to rotate the chain while the chain in a circular form is spinning in an axis. Because when it spins, it gets energy and then it starts to swing around and around to change its position, speed or direction. Because of the length of the rope or the chain, it will always take a circular shape. As long as it keeps spinning fast enough, it will stay in air as a circle. On to the next one then. So apparently this is called snake pendulum. Let's see. Oh, look at that one. It moves like a snake. I apparently broke it. Okay, so it moves like a snake. Why does it do that? Set a period, the motion becomes seemingly random and then gradually as a snake pattern returns and cycle repeats. The timing of each pendulum depends upon its length. As the weights hang up, lengths as the periods different, making and breaking beautiful patterns as because of the different lengths. Look at that! Look at that! So the balls start oscillating, forming a rhythmic pattern like a snake. Then on to the next one. So this one's called Tarangi Geet or wave motion. I'll just grab a photo. So let's see what it does. Oh, it moves different. Thin rods and red balls at close intervals are joined by a thin horizon strip, which is this. So, as you turn the lever, the horizon strip oscillates because of the high moment of inertia of the weight hanging below. A disturbance takes several seconds to travel from one end to other to other. Thus, transverse motion of the red balls at the ends of the rod can clearly show wave reflection, partial reflection, and independence matching. Okay, but it makes a wave propagation. Let's see that one. See, it takes time. On to the next one. Wait, fishy. On to the next one then. It's called simple harmonic motion. It's like a peripheral of a disc. It's connected to the motor driving with a constant angular. As you can see, the velocity light projects the position of this ball onto the base. The shadow of the ball shows a phase relation with displacement, velocity and acceleration. The relationship between these quantities in a simple harmonic motion and the corresponding quantities in uniform circular motion is demonstrated. It's stabbed. On to the next one then. So apparently this one is a wave motion same as this one, so we're not gonna bother that. It's called Lysatrus figures. Yeah, the pattern called Lysatrus figures are guaranteed using laser tool models. Ooh. What is that? Wait, it looks like it's forming a one and moving in different directions. Oh, now it's like a snake. Oh, it's a leaf. It's moving like this on the phone, but it's something else. In real life, it's like a leaf. This is what the race is doing. It's thick, it's moving. And it's cooling. Again. So this is because since the mirrors are mounted before the motor at an angle of the laser beam, it's literally fast in reflection. Two mirrors are placed in a mutually perpendicular axis. So let's go and then. So this one is apparently called nodes and antinodes. Press the switch and watch the loops. It's already doing that. Let's see. Oh, all of them are doing that, but this one is the fastest, slowest. So, form depend. The wave straddling around stretch string is reflected at the end points and going. See, it's making a wave type structure. So the stationary loop formed by the string. The number of loops formed depends on the frequency of vibration, material of the string, and tension applied on the string. So let's go on then. This one's called virtual harp. Move your hand horizontally and vertically at the points of pipes. Okay, that's the button. Okay. It's that because it's not. Okay, so this happens because each time your hand passes through the gap between any pair of the pipes, your hand is sensed and particular music note is created electronically. So, creating a virtual environment where without touching a string or hitting a rod produce musical notes. As you move your hand, you will listen to octave music. Okay, so let's move on to the next one. So this one's called Pipes of Pan. Put your ear on the opening tubes. I don't think this one, do you read this? But this one, you're like, and it goes even deeper. So this happens because the principle of resonance, in which we do listen only to sound pipe of the frequency of which is equal to the natural frequency of the pipe. So on to the next one then. So this one is called Rising Arc. I'll just take a photo. So press the switch and observe how the arc moves up until it breaks at point. It broke there. Let's try it once more. Okay. So the arc strikes across the narrowest point, the gap where the insertion of air brakes applying 25,000 volts across the terminals. The arc is forced upward by a combination of heat and electromagnetic effect because this is a good conductor of current and heat. So thus the arc takes an increasingly longer path until applied voltage becomes insufficient to maintain the arc. This phenomenon is observed in horn gap arrests to provide a temporary thing to protect electrical equipment and transfer high voltage. Let's try it once again. Yeah. Okay, I think the insides are done now. Oh, wait, floating ball. So this one's apparently called jumping disc. So we have to press the button and observe how the aluminium disc jumps up against the force of gravity and floats in air. So I'm just gonna press the button. Please press the button. It's going higher and then it comes down. So the alternating current flow through the coil sets up a fluctuating magnetic field, which induces a short-circuiting current through the aluminum disc. This current sets up another magnetic field around the disc. The repulsion of two magnetic fields causes the disc to jump high. In this exhibit, the magnetic force is greater than the force of gravity because of the metal that's in there. Let's press it one more time. Okay, then there's the last one.
Which one?
So this is called floating ball because of the air that's coming from down. It's gonna float, but then at the end, because of the air pressure, it's low. It's gonna fall. So let's see. It's going to the side. It's going to the side. One of them is gonna fall down. I think it's the yellow one. So let's put it in a little side. Oh, that just jumped off. Okay. Side press the button. See, it fell down because the air pressure is less. It falls down. Okay, so this one was the last one. Inside, let's go outside then. We've taken the pictures of the dinosaurs, so there's nothing to explain in there. Let's just put it in the slideshow. Okay.